We're going to find the area of the region that lies between the two curves, y equals x squared and y equals x plus 2. Now this requires a graph so we can figure out which curves are on top and where. But in order to draw an accurate graph, we're going to set the two y coordinates equal to each other to be able to solve where they intersect first. So this is a quadratic, so we need it equal to 0, and then we hope to factor. So we get that our intersection points are at 2 and -1. So when I go to draw my graph, okay, y equals x squared is a parabola opening upwards with its vertex at the origin. Equals x plus 2 is a diagonal line with a y-intercept of positive 2. So this point must have x equals -1, and this point must have x equals 2, and we are then finding the region in between these two curves. So my area is going to be the integral of the curve that's on top, which is the x plus 2, minus the curve that's on bottom, which is the x squared, integrated from x equals -1 to 2. It is always better to clean up the integral before you actually take an antiderivative. Okay. So we end up with 1/2 x squared plus 2x minus 1/3 x cubed, evaluated from -1 to 2. Okay. So 2 squared is 4, times 1/2 is 2, plus 2 times 2 is 4, minus 2 cubed is 8, times -1/3 is minus 8/3. Now I'm plugging in -1. -1 squared times 1/2 is 1/2, minus 2 plus 1/3. Okay. And when we add these, we get a result of 9/2 for our area between these two curves.